All right, so we're now moving on to the last part of this unit, which is just going to be solving multi-step equations now. So before we were just doing one-step equations, now we're going to take this a little bit further and do multi-step equations. This video is going to be broken up into several parts. So this is our first part of this unit, first part of this section that we're going to watch. So by the end of all these different parts of these videos, you will know how to solve a variety of different multi-step equations. So for this video, we're going to solve just regular multi-step equations that don't really have much going on to it. And then we'll probably also do a question with distribution. And then the other parts will be left for the other videos that we have for this. So for this video, we're just going to pretty much be focusing on just solving pretty straightforward multi-step equations. And then multi-step equations where you'll have to simplify or use distribution first before you go ahead and start solving. All right, so it's just going to be a couple questions that we're going through. First, we'll talk about the order that we will do things, and then we'll get into some questions. All right, so first, if I give you this expression, 5 times 2 minus 3, and I ask you to do this, you would use your PEMDAS. And we would then start with our parentheses and work our way down this way and do it in the correct order until we get and simplify everything that we can. So the first thing that we would do here is we would multiply. So we will multiply, and I'm putting this in blue because we're going to see how we're going to tie this in later on. But 5 times 2 will give me 10. So now I'm left with 10 minus 3. Then after I do multiplication, I would then move on and do my subtraction. And 10 minus 3 is then equal to 7. So we can say that 5 times 2 minus 3 is equal to 7. Right? Now, one of the things I explained this to you guys before is when we're doing our PEMDAS, let's just imagine that we have this big box here. Right? And we open up this box. And as we're using our PEMDAS, we're putting it inside of our box. So first thing we do is we use our parentheses. That means our parentheses is going to go all the way at the bottom of the box because we used it first. Then we would do our exponents, then our multiplication or division left to right, so it doesn't necessarily need to be in that order. Then our addition and subtraction. So when we put them inside of our box as we're using it, they're going to go nice and neat. But if you notice, what we use first is at the bottom of the box. So if we wanted to try and undo and take things out of this box, we're not going to reach in at the very bottom and pull out our parentheses first because then it's going to make everything else in here get messy. Everything's just going to fall all over and it's no longer going to be a nice, neatly stacked box. So when we are undoing or solving an equation, we are actually going to go in our PEMDAS in reverse because we need to be able to take out everything nice and neat that we did. What we did last in our PEMDAS will have to come out first in order for this box to remain nice and neat. So that means that we're actually going to go in the reverse order. So when we are solving, if I give you 5x minus 3 is equal to 7, and then the reason why I said I wrote that in blue is you'll see, we know that this x is going to be equal to 2 just based on the problem that we just did. But I'm going to show you how we do our PEMDAS in reverse. So when we are solving or isolating a variable that has more than one operation being done to it, we're going to go in PEMDAS in reverse. So we look and see, okay, what is being done? So if I were to read this out loud, it will be 5 times x minus 3. So that means that we are multiplying and we are subtracting. Whoops, I keep doing the addition. And we are subtracting. So since we're doing PEMDAS in the reverse order to solve for an equation, I need to first get rid of that subtraction. And to get rid of subtraction, the inverse operation is addition. So this minus 3, I will then need to add 3 to both sides to keep my equation balance. And minus 3 plus 3 I know is equal to 0. So now I'm just left with 5x is equal to, well, 7 plus 3 is equal to 10. So you see, we're now at this part here that we got that 10. All right, so now I say, okay, I did my subtraction, so I can cross that out. All I'm left with now is my multiplying. So it is good, I think, for you to write out your PEMDAS and highlight. And the inverse of multiplication is division. So that's telling me I'm going to divide each side by that 5. They cancel out, show your work. X is then equal to 2, which we knew it was going to be because we originally wrote this problem as an expression. All right, but I just wanted to show you that when we're undoing and solving an equation that has multiple steps, we need to do PEMDAS in reverse. And the reason is when we were to do it as an expression, it gives us this nice and neatly packed box. And if we want to be able to take things out of it and keep it nice and neat and us for it to be legible and actually be able to do, we need to take things out from the top and work our way back down to the bottom, which then means we're doing our PEMDAS in the reverse order. All right, so there's just going to be just a couple of questions that we're going to do for this, not too many, and then we will, of each kind. So there's going to be 1 or 2 that we do with this, and then we'll do a distribution problem. And then that'll be it for this video. All right, so let's go through our first example. We have 2x plus 13 is equal to 7. So once I see a multi-step equation, I'm going to suggest that you write out your PEMDAS and then draw the arrow going up, reminding you that you're doing PEMDAS in reverse when we're solving. And then you go through and read, okay, say it out loud. What operations are being done to my variable x? Well, 2x is understood to be 2 times x, so that means we are multiplying. And I see plus 13, so that means we are adding. So those are the two operations I need to undo. So then I'm going to ask myself, well, what is the inverse of addition? Well, that's subtraction. And what's the inverse of multiplying? That's division. So now I'm going to start from the bottom and work my way up. So I need to get rid of addition first. So since it's plus 13, I'm going to subtract 13 from both sides. Because 13 minus 13 is 0, and it will undo each other. So now I'm left with 2x. Well, 7 minus 13 is negative 6. So 2x is equal to negative 6. I can cross this out because I did it already. Now, all that's left for me to do, because I looked at this problem beforehand, is my multiplying. And now to get rid of my multiplying, I just need to divide each side by 2. And that means that x is going to be equal to negative 3. All right? Now, when we're solving for our x or a variable, it's important that you understand that we need to get that x all by itself. So that means we need to solve for when it is 1x. So if it's a negative, we haven't isolated it, we haven't solved for it. If there's anything else being done to it, a square, being multiplied by 2, added by 3, we haven't isolated. And the same thing with the other ones. Once you solve for your answer, you can go ahead and plug it back into your original problem to see, does this hold true? So does negative 2 or does 2 times negative 3 plus 13 actually equal to 7? And it does. So we can check our work. All right, let's go on to another problem. All right, so for our second example, we have 14 minus x over 3 is equal to 36. So once again, I see there's multiple operations, so let me go ahead and write my PEMDAS out. And I'm just reminding myself I'm going in a reverse order. And now let me figure out what actually is being done to this. So this first one, 14 minus x over 3, a lot of people have trouble with this. They don't realize that this 14 is actually being added to our variable, because we could rewrite this if we wanted to. I could rewrite it as negative x over 3 plus 14 is equal to 36. As long as if the signs that we have with each of our terms remain with them, we can go in the other order with addition and subtraction, because 5 plus 1 is the same as 1 plus 5. Or negative 5 plus 1 is the same as 1 minus 5. They are the same. So we can rewrite the order if we needed to, be able to visually see it. However, when you see that it's separated through a term, so this 14 is its own term, and we know that it's its own term because it's being separated by a minus or a plus sign, and that term is positive, then that means that it is being added. So this plus 14 or positive 14 is being added to our variable. Even though it doesn't say plus 14, it's understood that a number without a sign in front of it is positive. So that is understood to be an addition. And then we see the fraction. Well, fraction means divided. So here we are adding and dividing. So now our inverse operation of addition, subtraction, and our inverse operation of division is multiplying. So by doing all this up front, I've essentially solved this problem already because I know what I need to do. So I look and say, okay, I need to get rid of my addition. Well, here's my addition of positive 14. So I can get rid of 14 by subtracting. So I subtract 14, and that will give me 0. What I do to one side, I have to do to the other. So now I'm left with negative x over 3 is equal to, well, 36 minus 14 is 22. And that's the thing. Some people don't realize that this negative needs to stay with it as well. After they subtract that 14, they'll write this as a positive x over 3. If that term was negative to begin with, it needs to be negative until you change it through an inverse operation. All right, so now remember, our goal is to get x all by itself. So when I do this next part, so I've already did the subtraction, and I know my operation or inverse operation of division is multiplying. When I go and multiply, I'm not just going to multiply by a positive 3, because 3, a positive times a negative will still give me negative. So when I see that my variable is inverse, or my variable is a negative, when I do my inverse of multiplying or dividing, I'm also going to include that negative, so that way a negative times a negative will give me a positive. And what I do to one side, I have to do to the other. So I'm multiplying each side by negative 3. These will cancel out and give me just a positive x. And 22 times negative 3 is negative 66. And that will be our final answer. If you wanted to check your work, plug it back in. Does 14 minus negative 66 divided by 3 actually equal to 36? And that answer would be yes. because a minus negative will turn to a positive, and then we'll get 14 plus 22, which is 36. All right, let's go ahead and do another example. We might have one or two more, and that'd be it for this video. All right, so now we have this problem. 5 times 2x plus 1 minus 1 is equal to 19. All right, so now when we see here, well, we're going to write our pemdas because we have a lot of things going on here. And I see, okay, we're going to do this in reverse order. I see I have a parentheses. So I might focus on this parentheses first, but there's nothing I can do inside this parentheses. So when we actually have this parentheses, what we need to do first is to simplify, all right? There's other ways you can do this. I'm only going to teach you one way for now because we're just learning it. Once I feel like we're really strong, I can show you a different way we could actually solve this problem. And if you already know how to do it, you can go do it right away. It doesn't really matter. But when we see parentheses, we're not going to actually focus on that. We're going to try and get rid of it. So what we do then is, well, what do parentheses mean? Parentheses mean multiply. So we're going to actually simplify. So I'm going to distribute this 5 in. And now I'm going to get 10x plus 5 minus 1 is equal to 19. Right? So I'm simplifying. I am not doing an inverse operation here. So I'm not multiplying 5 to both sides because I'm just simply simplifying one side of my equation. So you see there's a difference. When we are doing inverse operations, we're coming up with that number and we're adding it to our equation. Here, we're just simplifying to one side. So we are not doing it to both sides. If you need to, what you can do is you can draw a line going down your equal sign. And as long as if you're not moving something to the other side of your equal, then we don't need to worry about our inverse operations. If we're staying on just one side of it, we're simply just simplifying. And the same thing here. Before I start solving, I'm going to simplify because I can actually do 5 minus 1. And 5 minus 1 is equal to 4. So I simplified and did everything I could do first before I tried to move on to solving for my x. And now I'm left with 10 times x plus 4. So now I have a multiplying and I have an addition. So the inverse of addition I know is subtraction, and the inverse of multiplying is dividing. So to get rid of this plus 4, I will subtract 4. So now I'm left with 10x is equal to 15. The inverse of multiplying is dividing. So now I will divide each side by 10. So x is equal to 15 over 10. We never leave our answer, though, unsimplified. So we will rewrite this then because they're both divisible by 5. So x is then equal to 3/2. If you wrote your answer as 1.5, I would accept that as well. All right, but this will not be accepted as a full credit answer because you did not simplify. All right, so that is it for this one. And let's go ahead and actually, that's it for this video. All right, I'm going to give you a question for you guys to do now. That's going to be one. Some of them will hopefully be a little bit easier for you, and then one's going to be pretty challenging to see how you guys can do.